Good morning, everybody. Good afternoon, wherever you are in the world. I am Pierpaolo Vezzosi. As Heather was saying, I'm in the product management team of the SAP Analytics group. And today we're going to talk about the way we can access to HANA and to BW and to third-party data sources using our semantic layer and Web Intelligence. So I'm going to show things which are already available in the product today. So in theory, there is no problem for future, for legal disclaimer and future functionalities. But I might say something and will tell you that is not yet into the product, which will appear in new versions of the application. And so in this case, we apply this legal disclaimer saying that things which I may say about the future might change because we still have plans, but we have not yet coded the functionality into our products. And so, as Heather was saying, I'm speaking today, but we have also Gregory Botticchio and Olivier Zonghi on the call. If you have any question, please write your question into the chat line, and Gregory and Olivier will answer. And if something is left over and we have time at the end of the session, I'm going to give some answers on the phone if necessary. Right, so the agenda is quite packed. There will be very few slides, but mainly a demo of the product. And so we start with talking about how we are accessing SAP HANA with Web Intelligence and with the semantic layer in BI 4.2 Service Pack 3, so the direct access and the online access. Then we will talk about accessing BEx queries with the new BEx Universe functionality. And finally, I'm going to show you the concept of linked universes, which was available in the previous BI XI 3.1 version, and we brought back into BI 4.2 Service Pack 3. So, until 4.1, you were able to access HANA, BW, and third party in different ways. We can group those ways into an advanced and smart manner to access the data. So, advanced ways were the universe, and the goal of advanced and universe connections are to make a customized model on top of your existing data. With that, you would access HANA tables, for example, and third-party databases table, and build your own universe, so your own business model on top of those tables, and use your own business terms and your own organization of the information. And then there is the smart access, which is the automated universe and direct access. And in that case, the goal is making it easy to connect to the data source. For example, when you were creating a universe on HANA, we were automatically building the universe for you, so that you had to do nothing, just create it automatically and then publish it to make it available. When you were connecting to, and you are connecting to BW in Web Intelligence, you connect directly to the BW BEx query without even creating a universe. That's the direct access. And so the goal there is go fast, make it inexpensive, and easily connect to your data sources. And that was what we proposed until BI 4.1. In BI 4.2 Service Pack 3, we added some more ways to access the data. First of all, you see that the automated universe for HANA moved from the smart to the advanced, because it is still there, but we think there are now smarter ways to connect to HANA. It is advanced because with HANA now you can, in 4.2 SP3, still build universes automatically onto HANA views, and you can use them to further customize them and make them more fit to what your business is asking for. In BI 4.2 Service Pack 3, we also added the linked universe functionality available for all the different data sources. And so I'll show you at the end what this means, and it gives you much more flexibility when you want to build a complex BI project on top of any kind of data source. So it's third parties, it means any kind of database, included HANA. Finally, on the smart part, we added two new ways to connect to HANA, the direct access and the online access, which enable you to more easily connect to HANA directly from Web Intelligence without the need to build a universe. And I'm going to show that. Actually, I'm stopping the slides here now, and I'm going for a demo of the functionality. So I'm launching now the BI 4.2 Service Pack 3 platform. I log on. And I'm creating a new Web Intelligence report. So you see here that when I launch the new Web Intelligence panel, actually I'm using the HTML UI of Web Intelligence. I'm not using the Java applet anymore. That's because we know that Java applets inside internet browsers are going to be deprecated by the browser vendors. And so we decided to invest everything onto the HTML panel. And so in the upcoming service packs, you will see all the functionality which today is into the Java applet go into the HTML query panel and HTML client tool. So in the future, you should be using the HTML connection client rather than the Java client. So you see here the different connectivities I have into my sources, and the first one I wanted to show you is the SAP HANA connectivity. This is what we call the HANA Direct Access technology. When I connect to HANA with the Direct Access, I don't browse anymore for a universe. I browse directly the connections I have available onto the database, and here I see all the different HANA connections which are being published. So here, for example, I see that in this HANA server, I have multiple packages in HANA. I select one package, and here are all the HANA views inside this package. Okay, so I click on the HANA view, and when I click OK, automatically I've got the query panel displayed. So I created absolutely no universe. Actually, there is a universe created on the fly. You don't even see it, but that's to enable us to show you the content of the HANA view. What you see here on the left are all the different objects available onto the HANA view. And given that I used an OLAP connection to HANA to browse the system, I can see the hierarchies which are inside the HANA views. So if you have HANA views with no hierarchies, you will not see them, but if there are hierarchies and you access with an OLAP connection to the system, all the hierarchies are here available for you to query. So let me build a simple query here. For example, I'm taking the store geography, I'm taking the store type hierarchies, and the amount measure, for example. And given that this is hierarchical query panel, I can see the content of those hierarchies here. For example, let's see that I have in my store geography, I have all the members. I have Canadian store, stores in Mexico, stores in the US, and then I see that below that I have different states, different cities, and different stores into each of the cities. So for example, I can select Canada, Mexico, USA, and also all the descendants of these stores into the USA. So you see here that I have only the first level for Canada and Mexico, and all the lower levels for USA. I click OK. Store types, I can take all of them, for example, and all of the children of the store types, which are all the stores actually. I click OK on this, and then I can run the query. So, given that I've used the query panel, the dimensional query panel with an OLAP connectivity, I can see all the information in hierarchical ways. So here you have hierarchical columns, so I can see all the different stores, and I can open now the geography and see, for example, all the stores which are in Mexico, all the different values for each store, and here I see the aggregation done for the whole country of Mexico. And here in the USA, for example, I have different kinds of stores, and if I open it, I see what are the different values for each store in each state of the United States. Right, so I created this very easily. Instead of creating a universe again, I connected directly to the HANA system, selected the HANA view, and just queried the view without creating a universe at all. So I ran actually a query, so I took a part of the data, I brought the data here into Web Intelligence, and now I'm doing all the calculation within Web Intelligence. And that's the direct access. It's easy, because you don't have to build a universe anymore. The other way to connect to HANA is the online access. So again, let me create a new Web Intelligence report. And now I'm selecting HANA Online. As before, I'm going to browse through the connectivities I have published to the HANA system. The difference here is that only relational connectivities are available. Hierarchical connectivities, OLAP connectivities are not yet implemented for the online experience. So here I'm browsing a new server. By the way, this is a HANA 2 server because the new HANA 2 versions already works with Web Intelligence with the semantic layer. And I'm opening this package, and from this package I'm opening this view. This was a flight view. Alright, so here I'm connected online, meaning that whatever I do on the screen is being translated into a query into HANA. And so now look at this. I selected the view, I click OK, and here I have no query panel at all. I go directly from the HANA view to the report, which means that whenever I drag and drop something onto the screen, I'm going to actually send a query to HANA. Let me make a very simple query. So this database is a database which is used to monitor the times of flights, and so we can see what are the flights which are in delay. This data is data about flights in the United States from 2014 until June or May 2016. So it's 2 years and a half of flight, and the view here contains 14 million rows. So I'm actually running a direct query onto an online query onto 14 million rows into HANA. So I'm taking the carrier, so the name of the air flight company, the time it actually took, the average time it actually took to all the flights to get to arrival, and the time which was planned. So I'm dragging and dropping the information here, and here it is. So I actually ran a query onto 14 million rows table and views, and I got the result back immediately. So it actually took a few seconds or not even a second actually, to get the result back. And here I can do everything which I'm actually used to do when I build a web intelligence report. So for example, let me create, I make it a new page so you can see it better. I can create a nice heat map here. I'm dragging it here, and I can put information there. For example, I can check what is the best time to fly during the week and during the day. So let's take, for example, the block of time when airplanes arrive. So that it means that those are blocks, for example, from 6 to 7 a.m., from 7 to 8 a.m., and so on. That's the arrival time of the plane. Then I'm going to take, for example, the day of the week. So here I'm going to select, for example, Monday, Tuesday, Wednesday, Thursday, and so on. And then I'm going to look at the average arrival delay measure. And so here, let me make it a little bit bigger. So the screen resolution is quite small, so I'm not able to show. Let me do this. Okay, it's small, so I'm not able to see, to make it bigger for you. There it is. So here, for example, we see, and let me also change the fact that green is, there we are. No, it was the other one. Green is good and red is bad, which was the opposite. So descending. Here we are. Okay. All right. So how do we read this graph? We read this graph by saying that whenever things are green, it means that the airplane was on time or even earlier. When they are red, it means that the airplane was late. Okay. And so we see here, for example, that the worst time to travel with an airplane is on so it's Monday, Tuesday, Wednesday, Thursday. Is on Thursday between 8 p.m. and 10 p.m. Okay, so this is the worst time to travel. The best time to travel is actually whenever in the morning, and we see that Saturday and Sundays have actually a better experience. So there is less time, there is less delays into the flight. I can easily as well create an input control. So here I create a new input control. For example, I can filter the information by year. Here, click next, and click finish. And so here, for example, we can see that in 2014, there were huge issues on delays on Thursday and Friday at dinner time, let's say. Things got a bit better in 2015 because there is less red here, and they started to be worse again in 2016. Now, notice that whenever I click something here, I'm actually changing a filter, and so I'm running a new query into HANA. Each time I'm actually querying and aggregating 14 million rows and drawing the graphical here. So you see that the response time of HANA is very fast when you access with this methodology here. Okay, again, this is the online access. Whatever you do on the screen, it's a different query I sent to the HANA system, and I have no query panel at all because I see all the different objects of the HANA view, and I just drag and drop them into the report. And all the calculations are actually pushed back to the HANA system. All filters I put into the report are sent back to HANA as query filters in the SQL statement. So I really get the least quantity of data available from my HANA installation here. All right. So let me go back to the slides now. We have seen that we have the direct access on HANA and we have the online mode on HANA. So which one to choose now? We have different ways to connect to HANA. You can use HANA Online, you can use HANA Direct Access, you can use HANA Direct Access on a relational connectivity or on a no-lab connectivity, and you can use a universe. So which is the best way to connect to HANA? Actually, it really depends on what you want to do. From the usage we have seen in the past few months now that 4.3 has been released, is that the HANA Online Access probably is the best one, no, without probably, it is the best one for exploring your data. You've seen that the response time I've shown you into the demonstration is incredible. So you can ask very complex questions and get the feedback immediately. So we have some kind of fail-safe constraint by default. You cannot return more than 5,000 rows, but you can take this limitation out and return all the rows you want. But so in theory, we make sure that you don't stop your system if you are trying to retrieve too much data. Actually, if you have a 40 million rows table in HANA, you do not want to retrieve 40 million rows into Web Intelligence. But we are smart enough because by aggregating directly to the HANA system, instead of returning, for example, 40 million rows when I aggregated when you're showing you the heat map, we're just retrieving one data for each cell in the heat map itself. So we greatly reduce the quantity of data returned from HANA. And that's very good. Now, the problem with this online access is that there is a constraint, is that whatever you do on the screen, we have to translate to HANA SQL. And there are some things which we cannot translate to HANA SQL. So whenever, for example, you have a block and you create a variable in the block which depends on the block itself, for example, you use the where clause of Web Intelligence or the all or any for any into the Web Intelligence formula, we cannot explain to HANA what you're asking for. So whenever you do a complex formula containing this kind of block operators, we cannot push it back to HANA. And so you might find that you are limited into the request you do to the HANA system. And so in this case, you should use rather the direct access than the online access when you connect to the HANA system. Now, the good news is that when you're done your report and you know you have the information you have, but you are limited by the function, if you go to the data access tab of Web Intelligence, you can disconnect from SAP HANA. Clicking this button means that I'm moving from an online experience to a direct experience when connected to HANA. So there is still no universe, but now all the data is inside. When I click on the disconnect button, I'm actually retrieving the data into the report and I'm doing the calculations locally. And so I can actually add the functions, use the functions which are not available into the HANA online connectivity. Now, if you are on the HANA Direct Access, you can use the Direct Access on relational source or relational connectivity or an OLAP connectivity. Now, we have noticed that HANA is faster to respond when you use SQL rather than using a dimensional query, which is today using MDX. So you can use the OLAP query as I did before, but you have to know that those queries are going to go slower than an equivalent query done with SQL on a relational connectivity. So do use the direct connection on OLAP connectivities only if you really need hierarchies. If you don't, stick with the relational connectivity because it's going to go much faster. And then finally, you can still connect to HANA via Universe, and that's useful if you want to do a high customization of your information. For example, you can connect to HANA tables, or you can do multi-source universes, joining HANA data with data coming from other data sources. You can change the folders, you can change names, you can put filters, you can put everything when you do a universe. So there are things which enable you to modify the view your end users have of the information in HANA without having the access to the HANA view. So if you're not a HANA DBA, if you're not a HANA designer, you can still fine-tune the exposure of your HANA data to your end users by building a universe on top of that. Right, so those are the two functionality we added, HANA Online and HANA Direct. So while I'm here, I also wanted to show you something which is not related to HANA, but it's a good time to show it now, which is the concept of big numbers, which I was asked to present here. So in Web Intelligence, by default and until 4.1, we have the ability to use 15 significant digits when you do your calculations. Okay, this is good enough for the most part of your work, but some financial institutions told us that 15 digits is not enough when you want to do, for example, exchange between two different currencies. There are some situations where you go beyond the 15 current digits, and then either you lose money or you actually gain more money than you were expected when you do this workflow on top of an exchange rate. And so they asked us to go up to 40, to more significant digits. And so starting with BI 4.2 Service Pack 3, the Web Intelligence engine is now able to manipulate up to 40 significant digits into a calculation. So I'm showing you how this works. So I'm creating here, for example, a new column, and I'm just adding a simple formula, which is very small interface here, which is the ratio between the actual elapsed time and the real time of the real time and the planned time of the flight. Okay, so it's just a ratio I'm putting here, and here it is. So this, we can call this ratio. Okay, I'm going to change the format of this number so that we can see a lot of significant digits. So here and say 0.12345678910. So we have something like 20 significant digits there, even more. Okay, add. Okay, and so here you see that my ratio, actually, the calculation stops after the 15th digit. After 15th digits, I start putting some zeros, and I just put zeros there. Now, to see that we actually can manipulate calculations to more than that, we have to change at least one of the two measures we use to do the calculations, from type number, which is the default, to type decimal. Now, if I change to decimal, you will see that the last three digits of the ratio column, which are 000, are going to change to something else. So I click decimal, and you see here that now I have some numbers here. You see? Before it was 000, and I have some 1968 and so on. So let me go back to show you the difference. Click number back, and then I got back the 000s. Okay? Alright, and so by default, we always do keep the original settings of 15 significant digits. We did not change by default to 40 significant digits because we don't want you to see that there are differences in your calculations. So we have been doing this for the past few years, and we don't want you to come up saying that there is a bug here. So to make sure that there are no regressions, by default, all the calculations are done in 15 significant digits. If you want, you can turn the calculations to 40 significant digits by changing the types of the measures or dimensions from number to decimal. Starting from BI 4.2 Service Pack 3 as well, into the universe, when you create an object which has a numeric value, you can say that this numeric value is of high precision, and if this is the case, by default, Web Intelligence will set the decimal precision to the objects when you create a report on top of a universe containing the objects with high decimal precisions into a number, measure, or dimension. Okay, so this was the big number. Okay. Right, now the next one is the universe on BEx queries. Universe on BEx queries is something new we added into BI for the Service Pack 3, and the request there was from our customers, which was saying that it's nice that we can connect to BEx queries, but sometimes BEx queries are not friendly enough for our end users, and so there is the need to further simplify the look of a BEx query. And so starting from the Service Pack 3, now you can build a universe on top of a BEx query, and then you query the universe with Web Intelligence as if it was any kind of dimensional universe. And the goal of the universe on the BEx query is just to make the BEx query easier than to look than it was before. So here I have different connections to a BW system, and I'm going to create a new business layer. Here, sorry, I'm in Information Design Tool, the tool used to build universes, so I'm actually a universe designer, selecting an OLAP connection, and I'm going to author the universe on top of the BEx query, universe which then I can share and I can publish to my end users. So I'm taking a local connectivity to the BW system. Now the system now is checking what are the available BEx queries into the BW system. It takes a while because it's quite a huge server I'm connecting right now, but I wanted to do a real live test. Click next, and so here I can select the appropriate BEx query I want to connect. So instead of actually going to search for it, I'm going to time for it. I'm going to actually search for it because it's going to be faster. It's called the query variable age MDT. So you see that the search is quite fast. There is a search across all that thing. I have more than 1,000 views here. And to make sure I got the correct one, I'm going to display as well the unique name, so the technical name of the view. And this is the BEx query I want to connect. Click next. So you see here that I have a mandatory prompt asking me to set a variable. For the time being, I just click OK. And when I've done this, I see that I have all the different characteristics and measures and key figures inside of the BEx query. So, for example, from here already, I can say, well, actually, the region characteristic, I don't care. I don't want to bring it into my universe. So that's already a start of a simplification of my universe. And so here I got my universe created by default. So I didn't do anything. I just pointed to the BEx query, and the universe has been created by default for me. And now, if I were to run a query now, let's see what it looks like. I see that I have all these different objects into the customer view, into the customer characteristic, and so I have all of that. It's not very well ordered. Everything is flat and so on. So if I click customers, for example, and I want to see the customers available into my BEx query, it takes a while because again it's quite a huge content I have there. You'll see that I have numbers. So this is actually the key of the customer, which doesn't really mean much to me. I want the user name rather than the customer name rather than the key of the customer. And so I want to make it simpler, just making sure that the universe is much more consumable by end users. So I can start, for example, by creating new folders. So I information folder, for example, and I'm creating now a new measure folder. Okay. So here, all the measure, for example, I can delete those things here which I don't care about, and so I could do this for all the different measures, and then I can just drag and drop the measures into the measure folder. Here, for example, the customer, I don't care about all those details and attributes here. I'm going to delete all of them. So delete, actually, not deleting them, but not showing them to my end user, and then I drag the customer information to the information thing, and here the same thing I'm going to do for this other characteristics. So you see here now that my universe, when I open it in the query panel, it's already easier to use. I've got two folders, and in the folders I've got my objects here, and in the objects I don't have the choice I had before. So this is one way to simplify it. Now, if you remember, if you look at the customer names, if you look at the values, by default I have to choose the hierarchy because there was this mandatory hierarchy filter here. By default, I have the numbers of the customer. I don't like that. So I want that by default, my end users don't see the number, but see rather the name of the customer. So here I click on the Advanced tab, and I say that instead of displaying the key by default, I'm going to display the short text associated to this characteristic. So now when I want to show the values again, and again I have to choose the hierarchy because there is the mandatory variable, now I see the number and the name of the customer. Actually, my customers are bicycle stores across the world, so that's why you see those names here, the Moscow Bike Store and the Budapest the Sports Something Store. So those are the information I have into my BEx query. And so that's nice. So I know that my customers are actually bicycle stores. So instead of calling this thing customer, I'm calling this bike store. Okay? And the same we can do here. So this is now much more readable for the end user, which knows that those customers are actually the name of the bike stores I have in place. Now, one thing which I used on before, whenever I try to look at the data, let's do it again, I have to select the hierarchy I want to run into. That's quite annoying because to do it every time, I want to say, well, actually, all of my users will have to use the same hierarchy. So here I can set the variable. I can say that whenever this hierarchy variable is found, I can say, well, by default, you take the country hierarchy. I take this away, and I say this is not a prompt. So I will not be prompt anymore. Whenever I run a query, the country hierarchy 1 will be selected by default for me. All right, and so now I go back, I run a query, and you see that there is no more requests of choosing the hierarchy. I can select already my bike stores here, for example. The hierarchy has already been selected for me. And when I run the query, I see the name of the stores without I just don't see the IDs of the store, but I also see the names. So here this is a normal query panel with a hierarchical query panel, so I see all the information, and I can refresh the query and run it. So this time I'm done. What I have to do now is just to publish rather the universe I created into the platform, and then every user of Web Intelligence will be able to connect to this universe and see the information of the BEx query much more easily than if the user was connecting directly to the BEx query. Again, the goal of this interface is to simplify a BEx query. You cannot add things. If you click here and you want to add something new, you see that the only thing you can add are folders. Okay, so you cannot add new things. You can just delete things, hide things, rename things, move things around, but you cannot create new calculations or new objects into the universe, because we have to respect the syntax of the BEx query, which is make it simpler to be used by the end user. All right, and so that was the information about the universes on BEx queries. The next item is about linked universes. So here I'm talking about connecting to any kind of relational data source. I'm talking about all of data sources, but whatever you have here, HANA, Teradata, Oracle, everything which is relational, you can build a linked universe on top of that. So what is a linked universe? A linked universe is a universe which you build by using parts of another universe. So in this example here on the screen, the colors, I create a universe A and a universe B. Those universes are called core universes. And then I create a new universe C, and instead of writing it from scratch, I just say, well, universe C is actually inheriting the objects from universe A and the objects from universes B. And that's done. Now, the interesting thing is that whenever I do change something in universe A or universe B, automatically and immediately the change is propagated to universe C. So this is very powerful, because then this means that I can create various use cases which are highly requested by our customers and by our partners. So let's see some of them. Is the company use case. So that's exactly what I was saying before. You have created small universes. For example, you have a universe A which talks about customers, and a universe B which talks about products. And for example, you have two different teams or two different persons who manage universe A and universe B. And then those persons will be experts of their area. And then somebody else, say the project owner, will build a universe C inheriting information from universe A and universe B, and so there will be all the information from customers, all the information from products, and also in universe C you can add new objects. For example, you can add measures which link together the customers and the products, and we will see a demo of this in a few seconds. We call this the company in this case because the idea here is that you can create smaller universes, smaller core universes to work, very easy universes, and then put them together in a more complex but complete universe C. The second use case is the kernel use case. This is exactly the opposite. Here you have one huge universe which contains, for example, an exposure of all your data warehouses. You have thousands of objects, thousands of tables, thousands of joins into your universe. And then the benefit of that is that you can manage everything from one single place. So your universe tells this is the single version of the truth for all of your data into your data warehouse. But then you don't want to expose all of that complexity to each of your users. And so from universe D, you can derive a universe E, which is just a subset of universe D. You do this by creating a universe E, which is derived from universe D, and then you hide things from the original universe D. And so you can create a universe which contains only information from the HR department, and then you can create a universe which contains information only for the marketing department. But all those universe E and F are actually linked to universe D, meaning that whenever I change something in universe D, the changes will be automatically propagated to E and F if the objects of those which have changed are inside the universes E and F. Again, the goal here is to be able to have a single place of management, a single version of the truth, and then different, let's say, smaller visualizations, smaller models, which are easier to use for the end user. The The use case is what is done usually by our OEM partners. So OEM partners have, for example, applications which they deliver, and on top of the application, they also deliver Universe. Typically, for example, we have our partners which provide HR applications. HR applications come with a database and tables into a database. And so what those guys do is that they create a universe on top of the tables, which they provide with their HR solution, and they provide the universe to their customers. Now, the customers, what they do, instead of modifying the universe which has been provided by the OEM, by the partner, they create a linked universe which inherits information from the universe created by the partner. And so they, for example, extend their universe by adding personal information, customized information for each customer. So when the partner releases a new version of the universe, what the end customer does is just they replace the original universe provided by the partner with the new universe, with a new version of the universe, and the changes are automatically propagated to the linked universes which have been extended for them. Okay, so the idea here is that the partner can deliver new version of their model, and the end user, the customers, will be able to embed automatically these new versions into their applications quite easily. And so here, for example, Universe H, it's the red part, so whatever has been delivered by the OEM plus some customization in yellow, which is done by the customer H. Okay, so let me show you how this works. Here again, I'm working in the information zone tool. So here I've used the typical club database. I guess if you have been creating Universe in the past, you've been using this club database, which is the demo database we deliver with our solutions. So here I've created a very simple universe on club talking about customers. Here I got the data foundation, and here I have the objects of the universe called club core customer. I got information only about customers. And then what I did, I created, so let me close this because I don't need it. Yes, let me close that and close that so make more space. And then I created another universe on top of the service part of the club database. So here, for example, I have the service tables with the resource, the service time, and the service name, and I created a business layer on top of the of this service part. Now, what I did, I published those two universes to the platform. So now those universes are available to be consumed as core universes. The final step is that here, okay, I created now a derived sales universe. So here in this universe, I actually put only the information about the sales. So I have the sales table, the invoice table, and the sales table, and I created a few objects about that. Now, what I want to do now is to inherit the information of the customer universe, the service universe, and put them into this sales manager database. So you see here that in the universe property, there is a new tab called Core Business Layers. I click here, and I say that I want to add core universes. The system automatically goes to the platform, and I can browse and select which universes I want to connect to here. So here I say that I want, for example, the core customer universe. Click OK. Click Close. And you see that now I have a new set of a new folder here with all the objects which were in the club customer universe. And here you see the tables which were in the club customer core database. I want to add another core, and here I'm adding the service database. Service universe. There it is. Okay. All right. So here now I have the service objects, and I have the service tables in here. Now what I can do, I can now customize it to make it work. So for example, I go to the data foundation. Let me open data foundation now. And here I can join things together. So for example, I want the customer ID to be joined by my customer ID in the data foundation of the customer database. And the service ID, I want to join it to the service ID of the service universe, which is somewhere here. There it is, service ID. Okay, so I created my join. I reorganize the universe, the table, so that they are easier to work with. I just save the data foundation. I go back to my business layer, and I see that now the data foundation is taking into account those joins here. And now the new derived universe contains my objects, original objects of the universe itself, plus the objects which were into the core universe. So when I run a query, the end user will not see that they come from 3 different universes. The end user will only see this kind of visualization where, for example, I can take an invoice date coming from the sales database, let's say the country of the customer coming from the customer database, and the resort name coming from the service database, the service universe. When I refresh the query, I've got the results putting together, because now the 3 universes are treated as a single one when I generate the query. And so the benefit of this is that whenever I want to change something into the whenever I change something into the customer database, onto the service database, automatically the change is pushed into the derived sales database. And so, for example, here I can benefit by having different people working on the different universe themselves and then sharing the changes together. Obviously, now this universe here, I can change it. I can create new objects, for example. I can, let's say, it doesn't make sense, but I could take the service line and create a service line objects. The service line is coming from the club services database universe, and I'm bringing these objects inside my sales folder. I can create new folders here, and I say blah, blah, blah. I can even hide objects. So, for example, in my new objects, I don't want to show the customer last name and first name, so I make them hidden. And so, even if they're available into the original universe, now they will be hidden into the derived universe. So here I can actually customize the view of the core universes into the derived universe to show only what I want to show to my end users. Okay, and so I think that that's it for the demo and the slides today. We've seen that when you want access to HANA into BI for the 2 Service Pack 3, now you can still use the universes as you were doing before, universes built manually or automatically, but if you want to reduce the cost and go faster with your workflow, from Web Intelligence you can directly access to HANA either with a direct access where you run a query, which can be dimensional, and you bring the data into Web Intelligence and do the calculation locally, or you can use the online access, which brings data back from HANA each time you do something on the screen. We optimize the query, and we provide you a very nice exploratory workflow when you want to connect to HANA. We have also included the access to BEx queries using the BEx query universe. Actually, we made it simpler because with a BEx query universe, you can connect to BEx query and make it more fit to the requirements and expectations of your end users, of your business users, by, for example, changing labels, hiding things, or organizing the objects or the characteristics, the key figures in different parts of your universe, or pre-answering mandatory variables. And finally, we have seen the concept of linked universes, which were available in XI 3.1 and now they are available in BI4. And those linked universes enable you to be much more flexible when you want to build a large and complex BI project, for example, having multiple teams, or when you want to deliver a universe to customers who have to embed it and then customize it to their needs. So thank you very much for
Thank you, everyone, for attending our webinar, and I hope to see you online very soon. Again, thank you, Pier Pablo. Thank you, Gregory, and thank you, Oliver. It was so good to have you guys on. Really appreciate you guys supporting us. Thank you.
Thank you.